um, um, what your project is and why you chose it. My project energy transfer, since my teacher told us we have to do this. I'll demonstrate this by making a generator. The generator can only work manually, which means I will have to rotate the axis to power up a single light. I chose this project because it's simple and helps comprehend energy transfer very well. Also, I chose it because I remember that my dad's job he has many generators that produce electricity for lights or buildings, so I decided to use a similar tactic. What kind of energy is involved? My project starts off with mechanical energy because you use a axis to be able to move the motor and power up the lead, right? Mechanical energy is the energy of an object due to its motion, which is what my motor does. The mechanical energy is transformed to electrical energy. This is demonstrated by the motion of the axis rotates the band. The band rotates the DC motor, causing energy to move through the wires and into the light, making electrical energy because electric energy is energy created by electrons moving through an electric conductor. What energy transfer takes place? Well, the energy works as a source of electricity. When the axis rotates, so does the band with it, making the DC motor to move at the same pace with the band. Then, when the DC motor moves, the wires that are connected to it produce electricity, making the single light turn on. But when the axis stops rotating, everything stops flowing, which turns on the single light. How the energy is transferred? The energy all starts from the axis, which is mechanical, energy. When you turn the axis, the band turns, and the motor can only move if the axis moves. So when the motor turns, it transfers energy by using a wire that is connected to the light bulb to the single light, which is electric energy. I put something there. So, how much energy we'll start with? Well, to calculate it, you have to use voltage, which is V. Equation is V equals I times R. To calculate, pretty much what I got was 1.5 voltages. To calculate the resistance and current, you can use the following equations, which is R equals V divided by I, and I equals V divided by R. How much energy is lost in my project? Energy is lost by friction. Why? Because of the tip of the DC motor were to have more friction, it would produce more energy, but instead of the energy is lost due to friction, which is why it gives a low amount of volts. Due to this, if the DC motor had more friction, for sure it would produce more electricity, more volts. What the lost energy becomes. Remember, the energy cannot be created or destroyed. Well, knowing that energy cannot be created or destroyed, the lost energy turns into heat energy. Since the DC motor doesn't have much friction, so where does the lost energy go? It turns into heat. No more likely as thermal energy. Why? Because rubber and the tip of the DC motor are two objects rubbing against each other, which turns into heat. Also, like striking two rocks creates a spark, or rubbing two sticks together will eventually make a fire, which is like rubbing the tip of the DC motor with a rubber band. How efficient the project is? It is efficient because in my project, there's things you can find at home and or at work. Many of the things listed upon our but some in the toy car. So, keep going down. Keep going. Keep going. Let's see. What have you learned from doing this project? I have learned I've learned that energy can only be transferred or transformed to a different type of energy. So learn that everything that demonstrates energy transfers. Some energy is lost on the way. Like I said, lost, not destroyed, because energy cannot be destroyed or created. So learn that mechanical, thermal, and electrical energy is and that their purpose is to help us comprehend and identify energy transfer. Yeah.